So let's see. This is sort of a you get it or you don't moment, but it's if you don't quite get it yet, we just started talking about it. So give yourself some time. The first one, find a couple points. You don't have a grid, but you should still be able to determine, for example, that there's a point -2, 1. And there's a point -1, 1. Some nice whole number points. So the slope, it goes down 2 over 1. So the slope everywhere is -2. So if I want to graph it, I just graph what exactly? Horizontal line at -2. It's crazy. I like it. Now, really, let me point this out. This graph has nothing to do with the graph of the tangent line. This is the graph of the values of the slope. This would be a silly question to ask for the tangent line. What's the tangent line to that line? That line. What line is tangent to that line everywhere? Itself. A straight line is its own tangent line. I don't know if you guys are with me. Because what's the tangent line slope everywhere? -2. So just do right on top of here, right? So a straight line is kind of a silly thing to talk about tangent lines about. So we normally just don't. Alright, maybe. So what about this dude? What's the first thing I should map out?
Your values of 0.
Yeah, so it looks like it's 0 right around -1. Where else?
And kind of like at point 1.
Yeah, point something here. So maybe right there it looks like, right?
Yeah.
0.25?
And then around like 2 point.
Yeah, there's not supposed to be a hole there. Just didn't want to print it out, so I wasn't trying to be tricky. But around 3 roughly,
Yeah.
right below 3, but right there. And that's my only zeros, right? And real quick, just like we did before, anybody know what this might be? A function that would be represented by this graph?
Negative x to the fourth?
Doesn't have to be negative though, because the end behavior is the way it's supposed to be. So positive x to the 4th, right? And it could actually be x to the 8th or something, possibly, but more than likely it's x to the 4th. It's got 1, 2, 3 turning points, right?
Yeah.
All right, so it's at least x to the 4th. So the derivative should look cubish, is what I used to call it, right? Sounds like the guys that live next to the L's, I don't know. Elvish and cubish. All right. So now we start to draw the values of the slope. So where the slope is negative, I'm going to start to draw down, because it's negative down here. So it's really big negative here, and then less negative until it gets to 0. So acceptable stuff for me would just be like, that's beautiful. You don't have to be perfect. You could be if you want to. A little tear would come to my eye if you're all plotting the things and getting the slopes. It's awesome. But what's more important here is the idea of what's going on. I actually would prefer you to not get the exact value because I want you to apply the idea. What happens after this point?
You go to the inflection point where it turns from...
Yeah, so it goes from 0, now it's positive slope.
Yeah.
And then it's going to be 0 here again. So right in the middle of this somewhere is that thing I call the inflection point where the slope stops increasing and starts to decrease. And this is where they say stuff in the news like, if I have one that's going down, it's like, the economy is decreasing at a slower rate. Alright, so it's still getting worse, just not as fast. And that's kind of related to the whole idea of the inflection point where you're like, please tell me that means you're going to actually take an upswing. Alright, so let's get back here. So now it's positive after this. Somewhere right here is going to be the maximal point. And then I got to turn around so I can go back. You missed it, Jeff. Oh, too bad for me. I got to turn around so I can get back through there. Okay. So I want to make that point right now. It's early in the class to talk about inflection point. Might as well use that word now because that's what the hell it is. Now the next 0 I got to get to here, somewhere in the middle here. Do you guys see how? Let me even use other terminology. It's too early for. You guys see why I would call this cup down? It looks like a cup. Some of you guys know what I'm bringing it. And here it's cup up, right? That could hold water, right? This couldn't hold water. So right in the middle somewhere, yes, sir.
What's the term called for when there's like a curvature between inflection points?
Well, I mean, the secondary is related to concavity, but you're talking about...
Well, there's a term for it. So like at the inflection point, basically there's a curve. It's like this way, and then on the other side of the inflection point is a curve that's like this way. There's a term for that.
Well, then that would be a true inflection point. So I don't know what more of a term. But let's finish this out. So here it's now what happens to the slope after this? It gets negative, bigger and bigger negative until about right here or so. Do you guys see that?
Yeah.
That's about where it stops getting more negative and starts to be less negative until it gets to 0 again. So right about there, I want to have my vertex of my little, not true parabola, but script. So it's going to get bigger negative, and then suddenly it's going to have a vertex about right here. I'm really overstating it, that's too bad. And then it's going to go back. Now it's still negative slope. These are still negative slopes. It's just becoming less and less and less negative. And then after this does sort of follow it. This is why students make this too big of a deal out of this. But oh well, it's getting more and more positive after that point. So our picture, this here, what does that look like? X cubed. So start off looking at x to the 4th. I know the answer to that should be something x cubed. That picture makes sense. Cool. So the last little thing, real quick. Shoot, I just can't. I got to show you this because it kicks too much ass.
In a good way or bad way?
So good.
Okay.
So good. I promised you earlier I would.
When you do the curve, how much like higher, lower,
I'm going to go through this really quickly. I've actually got it on this handout that I'm going to give you next time. There's a lot of little problems I want to work on next time. I just didn't quite get there yet. But how would I find this derivative? What would I do? Let me get you started. Yeah.
Sine x plus h minus sine x all over h.
Kick ass. So that's the procedure to find the derivative of a function that I don't know yet. Now officially we know the shortcut for, so if I give you x to the 7th, 7x to the 6th, we know the rule now. You can start to make it a part of your thing. But we have other functions that I don't know a rule for yet. So we'll quickly get those too, don't worry. This is kind of nice. Who remembers? Oh shit! Trig identities have a purpose? That's not right. Ooh, if you were in my class, you know that cosine is an asshole. Oh. So sine is nice. Sine says, all right, sine and cosine. So cosine, let's take turns. Right? So sine says, I'll go here for x and you can go there for h. As a plus sign, so I'll keep it a plus. If it was cosine, it'd be cosine, cosine. I'm for screw you. You got a plus, make it a minus, screw you. So that's why cosine's an asshole. So what's the other piece here going to be?
Sine of h.
Sine h. Cosine x minus sine x. All over h. Now watch, this is kind of kick-ass. And the background is this fact. This was shown up in the book. We talked about that a little bit. Right? We still haven't really proven it, but we will get to the point where we can. We're going to use it anyway. What's cosine as h goes to 0? Cosine of h, cosine of 0 is
1.
So I'm applying this limit rule, right? I can plug the limit into each piece.
Right.
That's right. Want to make sure everybody knows he's leaving. Cosine, yeah, no, leave. He's okay. Cosine of 0 is 1, so that's going to be sine x. Do you guys get that? And of course, sine x minus sine x.
0.
Kick ass. And then in the middle, I get sine h cosine x over h. But what's sine h over h limit? 1. So the derivative of sine is cosine. And if you did like we did with the graph of sine and you try to plot the slope, you would get a cosine curve.
And it's just slightly to the right.
And we all know it's 90 degrees off, but slope-wise, that's captured. The whole idea of it being 90 degrees off from each other.
Is cosine 1 over sine?
No. Cosecant is 1 over sine. Cosine is its own dude. Cosine is just the x
I mean
side.
the derivative of cosine.
Oh, derivative of cosine is negative sine. Yeah, that's going to take some more doing.
Oh, how does that can you do the same thing about the cosine?
Yeah, exactly. Totally. And you'll end up with negative sine if you do it, yeah.
And does that count as a rule?
That will now be a rule. I mean, obviously we'll never have to do this again. Because now we know the Drew sign is cosine.
Can I come in all my homework tomorrow and slide it under the door?
I'm not going to be back to campus until Tuesday anyway.
So then I'll lose a lot more time coming in.
No. I count, like, the days I'm not here don't count. That wouldn't be fair. Does that make sense? So if you turn it in on Tuesday, it's the same as turning it into tomorrow. I mean, so if you slide it under my door, I'll get it Tuesday, you're fine. So do that. You can do
Or I
that.
can slide it Tuesday morning
Or you can turn it.
before you get
That's fine. That's fine.
How many points is that exactly if I'm losing comparing that to yesterday?
I